Today's topic is finding inverses by graphing. So open your Inspire document of your guided notes, and yesterday we learned that in order to find inverses algebraically, we switch x and y. And I'm hoping by now you won't be surprised that I'm going to tell you that math is consistent, and that we'll do the same thing to find inverses by graphing. When you graph, switching x and y is the same as reflecting your graph over the line y equals x, that diagonal line through quadrants 1 and 3. So on page 1-4, we're going to do some samples. So we're going to graph f of x equals negative 1/2 x minus 3 and its inverse at right. So click over on the graphs page and do a Control-G to see your entry line and enter the name of that function. Again, negative 1/2 x minus 3. Hopefully you won't be surprised that you see a line that goes through negative 3 on the y-axis and has a slope of negative 1/2. Review of last week and last year. And now we want to also graph its inverse and see if it appears to be the reflection over y equals x. Now we did these algebraically in class today as your first 5-5, so I'm reminding you of that in the upper left-hand corner. I don't want you to have to do extra math during the video. I want you to already have your functions and their inverses, but I want you to see what they look like graphically. So I'm going to show you that again at the upper left. So there it is. It looks good. It looks like the new line, the purplish pink line, could be the reflection over the original, over y equals x from the original. But let's graph y equals x. And again, that seems nice. So at this point I would be satisfied, probably. One thing I want to show you that's kind of extra is you can change the way your lines look. You want to show all your entries and scroll over and change the line style, and I just choose dashed for my reflection line. I won't do that on every problem, it would take too much video time, but it's something you can play with. Okay, so at this point let's just go through the examples from the first 5-5. Number 2, I have the square root of x plus 3 is my original function. Graph it and see that. I may not have seen a square root graph before, but you'll be seeing a lot of it in the next, well, for the rest of the year. So after you graph that, graph its inverse that we found in class during the first 5-5, which was x squared minus 3. Now, that should cause you to pause. There's something going on that isn't quite right. We have more than the reflection. That left half of our parabola is not what we want to see. We only want to see the right half. The right half is a reflection. Hold your thought, and we'll move on later and talk about that. Our third example today was h of x is x cubed plus 1. Let's graph that. Again, you haven't seen an x cubed graph before, but we'll be seeing lots of them next chapter and for the rest of the year. When we found its inverse in class, we found it to be the cubed root of x minus 1. Again, as you're going through this, you're going to want the visual to make sure that it looks like the reflection over y equals x. And you could even look at a table of values and make sure all of your x and y values are switched. And we'll look much more of that in class. I just wanted to get you the basics for the video. And that looks great. It looks like we have a reflection over y equals x. So here's one more to try. We have f of x equals x minus 1 all squared plus 4. We found that inverse algebraically. We're going to graph it now. And hopefully, because we have something squared, you're not too surprised to see a parabola. Now in class, the last question on your first 5-5, we found its inverse to be the square root of x minus 4 plus 1, with the plus 1 outside of parentheses. And when we graph that, we kind of have the opposite of that other little conundrum earlier, where we don't see the entire inverse. And so to me, that's what seems unusual about that graph and the graphs in number 2. So if you go to page 2-3, the very important concept is that only one-to-one functions have inverses. You got the definition for one-to-one functions on the first day of the unit. You know the graph of a function is 1 to 1 because it passes the horizontal line test, the HLT. So that x minus 1 all squared plus 4 is not 1 to 1. If you go back and look at that graph, a horizontal line touches it in 2 spots most of the time. So we only want to look at part of the graph, and that's called restricting the domain. Here's how to do that. On paper, if you're graphing on paper, you would erase the part of the graph that makes it fail the horizontal line test. So in this case, we would erase the left side of that parabola if we had it on paper. We can actually also technically erase on our Inspire, and that's really cool. We can restrict the domain on our Inspire so that we only show the part of the function we care the most about. So add a graphs page, retype the name of that function, that f of x equals x minus 1 all squared plus 4. But don't push enter after it. After it, go to Control and the button to the left of 7 and grab that vertical line. That means such that, or restricting the domain to. And then restrict the domain. We only want to look at x's that are greater than or equal to thinking about the graph, 1. And there you go. Now I only have the right side of my parabola that passes the horizontal line test. When I Control G and type in the inverse of that 1 to 1 function, square root of x minus 4 plus 1, my graph will look much better, and certainly the reflection over y equals x. Have a great night.